SQL Server Performance Tuning with Grant Fritchey.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Before we start, I want to put out a personal message. For those of you who have followed my work and content for some time, you know that I started ClearMeasure 10 years ago. We're a software architecture company, and that's the type of consulting we do to help in-house teams be great, to jumpstart them along their way. So all of our work is programming in all of its various forms, and we've done a tremendous amount of DevOps and cloud automation work as well. And we're the North American consulting partner for Octopus Deploy. Now, I haven't done this very often, but I'm putting out a call for anyone who'd like to work with me. We've been running on a backlog of projects for quite a while now, and we need to grow. We need some more .NET software engineers, DevOps engineers who have Octopus Deploy experience and Microsoft Cloud experience. And we're also in need of a few more experienced software architects. And if you followed me for any length of time, you probably understand how I think about software. And if you like the way I think about it, then you'll absolutely love working with me at ClearMeasure. We need to hire some people pretty immediately. So if this has piqued your attention, please go ahead and apply online on the website. And if you have any questions, just send me an email at Jeffrey, Jeffrey, at clear-measure.com. And thank you for indulging me with the interruption. And here's our regularly scheduled episode. Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results through its ClearMeasure Way methodology. As an announcement, my architect forums are going strong. Signups for the next session are up. And if you lead a software team and are looking to collaborate with peer architect leaders, just go ahead and sign up at the link in the show notes. And for those of you looking for Programming with Palermo, my video podcast, you can just search in any of the podcast directories and you'll be able to find it. Now, the guest today on our show I'm really excited about is Grant Fritchey, a Microsoft Data Platform MVP. Grant Fritchey works for Redgate Software as a product advocate. He has more than 30 years of experience in the industry as a DBA and developer. He's an active participant in the SQL Server Central discussion forums, and he writes articles for SQL Server Central and SimpleTalk. He blogs regularly at scarydba.com, and Grant is the author of several books, including SQL Server Query Performance Tuning, as well as SQL Server Execution Plans, and many others. Grant also teaches classes on data management and databases around the world, and he teaches in the smallest user group settings as well as the largest events. So, Grant, welcome to the show. Happy to have you on here. How are you, sir?
Thank you. Doing great. It's a little chilly here in Oklahoma, but not too bad.
Awesome. Yeah, it's I would say nice short sleeve weather here in Central Texas. So, but we'll probably get what you have. Now, man, you've done so much in SQL Server, and you work for a company that does commercial SQL Server products. And I mean, there are very few people who've gone, as deep as you for how long. But before we get into that, which I have a lot of questions about that, roll us back in your career. And are there any key events which kind of led you into the database and kept you there and led up to what you kind of ended up working on all this time?
I started in IT. I was doing word processing. I was doing writing letters and stuff for people part time. And at a company asked me, it's like, hey, we've got this thing that we want to work on. It's called Paradox. Have you heard of it? I'm like, oh yeah, I know that. And they're like, okay, well, if you can start on Monday, we would love to have you. I'm like, oh, that's cool. That sounds great. So I went and bought a book on Paradox, and I got through about 4 or 5 chapters over the weekend. And I came in on Monday, and I was the expert. But that was a long time ago. I've worked with data the whole time I was a developer, and I did about 10 years as a developer, nonstop, and I was always working with data. And I was at a .com when the DBA quit, and they quit for very good reasons, by the way. Total different story we'd have to get into, but we'd been without a DBA or any data pro for a couple of weeks, and things were really, really getting bad. And I went into the boss's office, and I was having just a freak out rant, like this is wrong and this is wrong, and we got this problem, we got this problem. And the boss is like, okay, okay, calm down, and starts writing things on the boards. And I'm thinking like, oh, great, he's going to get somebody in here and fix all this stuff. And we get about 5 or 6 items on the board, and he turns to me and goes, okay, now which one do you think you ought to start with first? I'm like, what?
Me?
Hang on, what? He's like, well, yeah, I think we're just going to make you a DBA. It comes with a pay raise. Oh, okay, sure. You know what I mean? And suddenly, yeah, I was a DBA. I mean, I was completely and utterly lost, really. I mean, I knew some of the basics, but I was way over my head, and had to learn very quickly. But it was turned out to be a great choice.
Wow. You're the DBA. Congratulations.
Pretty much.
Yeah. Well, and databases have changed so much over 30 years.
Oh, yeah.
I'm constantly reminded that everyone working in software, half of them came into this industry 7 years ago or more recently. And then the 7 years prior, we had the other doubling effect. So what is that? Between 2/3 and 3/4 are 14 years or
Yeah.
less. I mean, that's
Wow.
2006 or more recent.
Wow. That's kind of horrifying to think about, really.
Well,
I'd rather not think about that. That's scary.
well, are there any big shifts that more recent developers and all the developers work for data just need to know about shifts in how databases have worked that would kind of continue to be useful just to know that context happened in the history of databases?
That's a great way to put the question. And I don't have a good answer. There are some massive shifts in the way data and data management works, and it's at two levels, right? There's within relational data structures, Postgres, SQL Server, pick your poison. There's been a lot of shifting in the way data is stored. Let's pick on SQL Server. I mean, you've
Mm-hmm.
got a bit more of an Azure crowd, so
Yeah.
let's pick on SQL Server for a minute. The SQL Server's got two ways of storing data now. It can store data as a column store, or it can store data as a row store. And by determining that you've got two different mechanisms for storage, well, then you've obviously got two different mechanisms for access.
Mm.
And the really interesting thing is that if you're looking at, say, oh, I'm primarily in analytical queries, so therefore column store is going to help us, cool. But did you know you can add non-clustered indexes to your column store index? So when you've got those little OLTP style point lookups, ta-da, you got help. Whereas the opposite's true. You can make everything, based on that point lookup, limited range scans, all that fun stuff, but then throw the column store stuff on top.
Mm-hmm.
So that shifting in the way we've got storage within relational structures gives us the ability to do best of breed. But then the bigger picture is stuff like Cosmos, implementing MongoDB and some of the other things that it implements underneath, and then stuff like Synapse, which is just SQL Server at its root, but it's an implementation of SQL Server that's radically different. Each of these things gives us a unique tool. So the modern developer, the developers today get to pick tools. And whereas before we had to well, okay, it's a data warehouse. Well, it's going in SQL Server. It's an OLTP system. It's going in SQL Server. We just tried to cram everything into one spot for good or for ill. Now you get to pick and choose. You really get to make some, it's choose your own adventure kind of thing. And you can be very successful that way. And in fact, if you are trying to force everything like, oh, well, I know MongoDB, so I'm just going to force all my data into Mongo, you're hurting yourself just as badly as if you're like, well, I know SQL Server, so I'm going to force everything into SQL Server.
Mm-hmm.
We're in a great position nowadays. We can pick what's best for the problem space we're working in. And I think that would be the one. It's not so much an evolution as an addition, but I would say that's the one thing I would emphasize to anybody, one of those people who've just come in the last 7 years. You're coming in after we've made the shift into this new world.
Mm-hmm.
I would want you to really emphasize the knowledge of that shift so that you can then get it into your brain and more into your gut to go like, okay, tool for the job, to what is my task? Not simply what do I know, but
Mm-hmm.
what is my task? And then therefore my task drives my other decisions.
Yeah, that's a good point. I think historically, a lot of people still go to straight SQL Server because it's so easy for downstream tools to integrate with it. And you may
Sure.
think, oh, should I store it in a different way? Maybe, but then do I have to rethink ETL? Then do I have to rethink these other things where I've got this whole ecosystem of tools and they all just natively know how to get into SQL Server and pull the data. So how do you advise people, and what are the canonical scenarios where it's like, maybe I should reach for Cosmos or something else?
Well, I mean, again, I tend to focus on task. So let's, for example, building a Internet of Things kind of stuff. I've got Raspberry Pis over here I play with occasionally. You're building out stuff with Raspberry Pis. You're on the edge, right?
Mm-hmm.
They call it. And you're hooking them up to a whole bunch of cars, and you're going to be collecting data from millions of cars all over the planet. Would you do all that with SQL Server? Yes. Is it going to do it well? And the simple answer is no. It it doesn't have an easy distributed collection system.
Mm-hmm.
So you're going to have a somewhat centralized collection system. Well, for a planetary, like I'm collecting data from Australia and the United States. Man, I don't wherever you put the server, somebody's suffering, right?
Mm-hmm.
So you're going to want more of a distributed data collection mechanism. You're also not necessarily going to want something that's really transactionally aware. I mean, does it matter that that Volkswagen bug in the Outback pinged you twice when it only should have pinged you once? Nope.
Mm-hmm.
It's just not going to matter. And so a transactional, limited scope data structure isn't going to serve that well. And could it do it? Absolutely, it could. I mean, and I'd be happy to sit down with somebody and tune their queries and tune their structures to make it run as fast as possible. But it's not going to work well. And so that's the key is identifying the situation you're in and the data that you're doing and the nature of the needs of that data. And that is going to drive some of the decisions, even though it's going to cause you some pain because I'm used to developing for SQL Server. Now, if I'm going to develop for Cosmos, it's different.
Mm-hmm.
And then differences, frankly, it means new learning, new pain, and new issues, and hey, new technical debt, yay.
Mm-hmm.
But at least you're facing the right tool for the task, and to me, that's the important driver. It convenience and knowledge, yeah, they're handy, but you really ought to be driven off your task as making those decisions for the right kinds of technologies. At least that's my 2 cents on it.
Yeah. Yeah. And another dynamic, I think, I could be off, but it seems between 2005 and 10, there was a big discussions about big systems, the monolith system versus breaking it up into multiple applications and then the microservices mindset. And
Oh yeah.
when it was just one, the term was the database, because of course there's only one, right? And
Right.
so now, how do you think of, and what should developers know about the ecosystem when you've taken a system and broke it up into multiple applications?
Oh wow. Well, good luck. Frankly, I mean, the situation we find ourselves in today, and I mean, I love it. Believe me, I am not going like, oh, it was so much better in the old days. It was not. It was horrible in the old days. Technology stank, and we spent most of our time dealing with how horrible the tech was.
Mm-hmm.
We are way better off today. That said, we still have problems. And the problems you're going to run into with some of the modern architectures where you are going with microservices is you're looking at a lot of little tiny wells, little tiny isolated stores for your data. There's a little sink. We've dumped all the data down inside there. Okay, cool. How do we get at it? Don't
Mm-hmm.
know. How does it correlate to other data that we're collecting? Don't know. How can we make, sure that we actually get all this stuff back together into a central location so we can do actionable intelligence on the information that we've collected? Don't know. Got to figure all that out, because you can't simply build a microservice and walk away. That data that microservice consumes or generates is needed in other places. And so you are going to have to come up with the database. Granted, and again, this is where new technologies makes a big difference. We've got the whole concept of data lakes, where your multiple locations, let them live in multiple locations, but query them from a single location. So you've got the ability to then take all those little isolated wells, all those little tiny things that you can't access and correlate, and get access to them and get them correlated, because that's just going to be a big driving factor for it all. That said, at the end of the day, fundamentals are fundamentals. You make a bad data structure, you make bad indexes, you make bad queries, you will have pain. And that pain won't go away just because you've got a data lake behind it. And so you are going to still be dealing with, the same kinds of issues that, in 1992, when I was first learning how to write a SQL query. It's the same today, right? You can write a SQL query badly or you can write it correctly.
Mm-hmm.
You can generate it from generated code, you can generate it well, or you can generate it poorly. It's always the same. I mean, you're really going to still have to deal with those fundamentals. But we are in better shape than we used to be.
Yeah, amen to that. I still occasionally have to integrate through data access objects or even ADO.NET, and did a little
Sure.
ODBC in the last 6 months. So yeah, the tech is way better than it used to be.
Oh yeah, I mean way better. But although I mean, like, I'm still running JDBC connections all the time from some of the software that I run.
Mm-hmm.
So it's,
Yeah, yeah,
hey, nothing's changed.
right,
As much as everything has changed, nothing has changed. Kind of
right.
fun.
Well, you've taken kind of the fundamentals and the mindset and how to do all this stuff. You packed it into several editions of your query performance tuning book, and your congratulations on your 2022 version book that just came out last November. So, the listeners can get that anywhere books are sold.
Yeah, pretty much. Yeah. A year in the
Yeah.
making, that one, because unlike a lot of times when you rewrite a book, I mean, you already know this, you kind of go in, you look at it, and you're like, this chapter needs a little updating, and let's search and replace everywhere where it says 2019, we'll replace it with 2022,
Mm-hmm.
and stuff like that. I was looking at my book, and I said, I don't like it anymore. I don't like this book. So I threw it out and I completely rewrote it from scratch, except
Wow.
for one chapter. One chapter I stole. That was the chapter on cursors, because nothing's changed. I did I did do a little cleanup and update on it.
In
But
24
other than
years.
that, all the other chapters are completely rewritten from scratch.
Wow. Wow. Now, did the latest version of SQL literally change that much stuff, or did you just find better ways to explain things?
It was much more about better. I mean, let's be honest. 2019 and 2022 SQL Server both brought in some amazing stuff that is unique and new. It's all of the active intelligence inside the query tuner, inside the query engine. Um, that's radically new stuff. But the main reason I restructured the book was because it had been mildly adjusted over almost a decade.
Mm-hmm.
Um, and it just needed to be changed. There were better ways to teach, better ways to break down the structures, better ways to organize the chapters, so that we weren't talking about recompiles before we talked about the optimizer. right? I mean, you kind of need to know
Mm-hmm.
what the optimizer is and what it does before you start talking about recompiles, because what's a recompile?
Mm-hmm.
What happens in a recompile? I don't know.
Yeah.
Look at the next 3 chapters away, and that'll give you that information. No. Let's tell people how the optimizer works, then tell them what recompiles are.
Mm-hmm.
Stuff like that. And it was just it needed a lot of love, and so it got it.
Right. Right.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
So now obviously DBAs need to go deeper, but every developer that's, calling to a database needs to know, have a certain level of competency, and hopefully they've, had some database classes, whatever, at their education. And I remember, formally going through the normal forms and Boyce Codd normal form. But what's your idea on how much of that theory is universally applicable, and what are the rules of thumb that every developer just needs to know? And if they don't know what you're talking about, they need to go and hit a bookstore and catch up.
Yeah. That's a great question. I like it. My biggest thing is because when we're talking performance comes down to the code. It's always down to the code.
Mm-hmm.
Yes, data structures matter. Normalization is actually a performance. There's multiple reasons. One of the reasons you do normalization is for performance. And
Mm-hmm.
I know people are like, well, wait, no. If you have too many joins, it slows performance down. It's like, no, not really. But we can talk about that offline. To me, it's the code. And so the one thing I would ask is that if you're generating your code, you're using in Hibernate, you're using Entity Framework. I love Entity Framework, by the way.
Mm-hmm.
Great tool. But if you're using Entity Framework in Hibernate, one of the other ORM tools, don't assume that the code it generates is perfect.
Mm-hmm.
In fact, assume that somewhere in the region of 5 to 10% of the code it generates is going to be garbage. And then you will need to write some SQL, and you will need to know how to write SQL.
Mm-hmm.
And it's only going to be about 5 to 10% of the code, but it's going to be the hardest 5 to 10%. Right? The easy stuff, that's automated. Right? You don't need to think about it.
Mm-hmm.
Insert into table. There's only really one way to get it done. The code can generate that just fine.
Mm-hmm.
But some of the select statements, some of the queries that you're going to need to run to pull your stuff together, if you're looking at generated code, most of it's going to be great, right? Most of it's going to work fine. But about 5%, and the hardest 5%, is going to require you to write it. And that means you will need to know what T-SQL is and how T-SQL works, and
Mm-hmm.
what's good T-SQL versus what's bad T-SQL. And maybe bring in a database developer, a DBA, some kind of pro who can assist you with that last 5% of the code. Because again, the other 95% can be generated just fine. You don't need to worry about it. And I know people complain about ORM tools, but usually it's one of two issues. Either the ORM tool's been implemented incorrectly, and that's possible, and then you get really, really bad code out the back door and all kinds of horrible things happen.
Mm-hmm.
Or you've hit that 5%. You've hit those places where, yes, the insert, update, delete statements all work, but the select, oops, that's not working well. It didn't generate well. We need to write some T-SQL. If you work well with your data pros, you'll be able to fix that little bit at the end with a little bit of work. But if you're not working well with your data pros, Yeah, you're going to generate about 5%, somewhere around the neighborhood of 5% of your code, and it's going to be really stinky code, and you're going to hear lots of screaming after it goes into production.
Mm-hmm. Yeah.
Seen it over and over again.
Yeah. With C# and JavaScript and HTML, there's static analyzers that can say, hey, you know what, that code, here's some warnings, or you might want to do that differently. Are there any go-to tools, in your opinion, that every developer just should be plugged into their tool set that can alert them to say, hey, I know you're using the Entity Framework, but stop, because regardless of the shape of your data and how big your database is, that's a bad query.
Right. Okay. So, well, there are some linting tools in SQL Server. I'm not going to get into which ones there are. There's a couple open source ones and some others. I would look it up. There are definitely SQL linters. The main reason I don't want to do it is because my company is bought into a couple of them and we push them. So, I mean, rather than you want a sales pitch, I'm just going to be like, yes, they're out there. Go do a search and you'll find it. Matter of fact, if you look my name, you might find some particular ones. But um, they are out there. And so you can go directly to your code, not worrying about what's running on the database. You can go to your code and get common code smells,
Mm-hmm.
identify them. Like, for example, the one that will come up a million times is select star. Is that a problem? No, select star is no big deal. If you want to get all columns from a table, what's the easiest way to do it? Select star.
Mm-hmm.
But what if you want the columns in a particular order? Okay, now we got to change. What if you don't want one of the columns? Oh, now we got to change. What if you find out that moving every single ounce of your data, select star, is causing you performance headaches? Oh, now you got to change. So select star itself is not a problem, but it could be. So it's one of those things you want to alert. Queries without where clauses, functions in where clauses. A linter can pick up all of these things. Then you want a monitoring system in place. Even in dev, I would have one in dev personally. Capture the queries that are causing you pain in dev, and so you can identify them before you get out QA, before you get to prod. So that means you are going to look at monitoring. SQL Server's got built-in monitoring, or you're going to look at third-party tools. The built-in monitoring, the two things I recommend, I'm actually going to be doing a talk on them in Takorama in Belgium. One is extended events, and the other is query store. Those both work in Azure. They both work in Azure Managed Instance. They work on SQL Server. They work on Synapse. Is different, but everything else they work within those. So those are the two I recommend because they cover the most ground and they give you the most material. It's just kind of a question of, do I need something very, very granular, extended events,
Mm-hmm.
or do I need something kind of generic and broad and aggregated, query store? So it's make that call which is better for you in a given situation and put one of those tools to work. That way you can identify the problem queries. Because again, a few of your queries are going to cause you problems. Catching those early is going to make a big difference. So start with a linter and then move into monitoring as you go.
I'm glad you brought up monitoring because I pay pretty good attention to Microsoft Build and Ignite and all the messages that they really push, and integrated with all of the Azure content and the build, test, deploy, and run in Azure, and even ARM templates and infrastructure as code. I don't hear the message integrated. By the way, when you're plugging into Azure SQL, enable these features. Here's Query Store. Here's how it works. Here's what it'll do for you. So I'm glad you mentioned those.
Well, though, funny enough, Azure Query Store is enabled by default.
Okay, so how then does it work, and how do developers get notified? Are you saying it's constantly figuring out what's bad? So how do developers plug into those alerts?
So, well, one, it can give you alerts. It doesn't by default.
Mm-hmm.
The alerts are what you would have to turn on.
Yeah.
But Query Store itself is running inside of Azure SQL Database and inside of Azure Managed Instance. Also, by the way, SQL Server 2022, Query Store is enabled by default on all the databases you create. But anyway, the way Query Store works is it's pretty low level. It's written into the engine itself. can't even get into some of the details on how it runs because I don't know. But it's very low level. It's capturing a lot of stuff, during execution. It captures and aggregates the queries, and it works off a query. So, like you have a stored procedure or a prepared statement from Entity Framework
Mm-hmm.
that's got 30 different queries in it. That's cool, but in Query Store it'll be 30 distinct entries, one for each of the queries.
Mm-hmm.
The reason for that is because basically the behavior of SQL Server is query focused. Yes, you can create batches. Yes, you can create procedures, but what actually runs is queries. And so when they built Query Store, they built it off that idea. Can you marry it back to the batch? Can you marry it back to the procedure? Absolutely. But the goal is it runs off queries. The information it captures is aggregated, but it is, average duration, average CPU, average IO, and standard deviation over time,
Mm.
so that you're not just looking at an average going, well, okay, it runs in 5 seconds, so I guess it stinks. Well, no, the standard deviation is, very, very small. So it really does run in 5 seconds. Okay, cool. Well, if we tune this, then it will run faster consistently. Or we say, okay, it runs in 5 seconds, but standard deviation is huge. Well, it means
Mm-hmm.
sometimes it runs in a millisecond and sometimes it runs over a week. Okay, now what? Well, now you're in trouble. Now you've got real work to do. But having just averages isn't enough. Having that standard deviation lets you get all that stuff. So the beauty of this is twofold. It's built into the database, so it's there, and you can query it separate from querying the data structures. So you can just go into Query Store and pull that information out. If I was a DBA, I would make this accessible to developers, but with one caveat in there.
Mm-hmm.
If you're having to do with GDPR or the California Privacy Protection Act or any of the other compliance regimes,
Mm-hmm.
Query Store exposes compile time values, other information. If there's hard coded values in the query, it exposes that.
Mm. You
So
never know
there's
what's in there.
potential for GDPR violations if you expose that data outside of production environments or if non-approved people are getting access to that data. So make sure that you've done your due diligence to protect that stuff.
Yeah.
Other than that, feed it to the development team. My gosh, they need it. Please, please, please let them know where the pain is.
Yeah.
That's so important.
I think I can see a Redgate product or an extension of Data Mask for that coming at some point.
Oh yeah, that might be on the list.
Awesome. Well, obviously, there's not enough information to go through everything to think about with performance tuning in just our short
Oh
time
yeah,
here.
yeah.
But
There's a rather thick book on it like that.
that's right. That's right. But I do want to. I kind of do want to dive into the work that you do on a day-to-day basis. I'd like to get the sales pitch. You focus on this. Redgate
Sure.
is the best of breed for commercial tools for SQL Server. What are the relevant commercial tools from Redgate that help with this, and how are they chunked up, and what are the different focuses? I'd love to have that sales pitch.
Okay, well, we make a lot of tools. We make a lot of tools,
Mm-hmm.
but I'm gonna focus on 3 areas: compliance, which we just brought up, DevOps, and monitoring. Now, our monitoring tool is SQL Monitor. Uh, right now, it is, I think, the best SQL monitoring tool out there. It supports AWS, it supports Azure, it supports on-prem, VMs, you name it, we do it.
Mm-hmm.
And we've got 5 different development teams working on it. Only 4 of them are working on the SQL Server side, but there are 5 teams working on it. And it's going to, well, it already does, but the big announcements aren't out yet. But I can still say this: it's going to support PostgreSQL, so it's going to be multi-platform as well. So
Mm-hmm.
I really recommend that tool. So monitoring is one. The other tool is compliance. We've got a whole series of tools around protection for your databases, to basically make it possible to give developers the one thing they want: production data, but give it to them in a clean fashion
Mm-hmm.
and in a small and fast fashion. So we've got this tool, Data Masker, which cleans the data, but we've also got a tool called Clone or Spawn, that. It has two names because there's a lot of development going on with it. But anyway, the clone tool allows you to make copies of databases fast. So you pay a little tax up front, create an image, and it basically takes about as long as a backup. Once you've done that, then creating a clone takes seconds, 15 to 45, give or take, second.
Mm-hmm.
Brand spanking new, clean data in your non-production environments, quick. So you can refresh your data over and over again, once a day, twice a day, once a week, whatever tempo fits your work, you can do, because you can do it fast. You're not sitting there waiting. Oh, well, it's a two terabyte database. I got to wait 3 hours for the restore to run. Nope. You can get the copy of this database in about 30 seconds. Cool.
Yeah.
So we've got that tool, and then we have got DevOps tool. And the DevOps tools, the big one is Flyway. We've gone through multiple permutations trying to figure out the right way to do DevOps with databases because it's hard. Flyway answers the problem. Basically, it uses a hybrid approach. Instead of state-based, which was our original tool, SQL Compare, how Redgate got started, compares two databases, finds the differences, and generates a script to set up those differences. Now that's state-based. The problem with state-based is some of the scripts, it's almost like ORM tools. Some of the scripts are hard.
Yeah.
And so when the scripts are hard, the state-based tool fails. So the worst problems, state-based just upchuck and can't do it. So the other approach is migration. Now, migrations is the foundation of Flyway, and migrations is basically just a manifest of changes. You've got a set of changes you want to run them in this order. Ta-da, you're up to date. You've got new changes. Cool. Let me see what's in the database. Okay, you're up to this point. Well, then I will run scripts after that point. Ta-da, you're up to date. Migrations fixes that big issue because you can, we need to adjust the way the script works. We're going to rewrite it. Awesome. We do that, and now it works. So off we go. Fixed it. Flyway. Yay. But it can cause you to sort of bleed dev into prod, meaning add a column, drop a column, add a column, drop a column, add a column, drop a column, all the same column, by the way.
Yeah.
Normal development, right? I'm not throwing rocks at dev. This is how you do it, right? You're experimenting, you're trying it.
Sure.
That didn't work. Try a different way. Okay, no, that worked worse. So let's try another. Cool. But when you deploy that mess into production, that's a problem. So Flyway Desktop is our latest tool, is a hybrid tool. It uses based inside of dev. So you just run a compare and you're tracking all of your object changes as objects. Ta-da, you've got history and all of the cool things that source control gives you at a database object level. When you can then generate migrations when you're ready to go to production, have that neat, clean migrations approach as opposed to the state-based approach, but only when you want it. So we've got a hybrid tool that's going to solve a lot of database DevOps problems. Most of them, in fact. I've yet to hit one that we couldn't figure out a way around at this point. But that's in a nutshell. Those are the three big areas where we focus. Now we've got a lot of other little tools, but those are the ones I would talk about: monitor, compliance, and DevOps.
Okay, awesome. Well, we'll look forward to that new Flyway coming out. I know it came from a Java background and heavy on non-SQL as well, right?
Oh yeah, it supports 27 different database platforms right now, and that's going up. But it's fantastic. And Flyway Desktop right now supports currently SQL Server, of course, because that's our bread and butter. Oracle, PostgreSQL, and I just posted a video to YouTube of MySQL. And that's pre-release. That's early days. But if anybody wanted to, I could tell you how to do it. There's a couple little cheats you have to do to make it work. But regardless, we're supporting MySQL. So that's Flyway Desktop is going to support all four of the big databases, and then we're going to expand it out into, it's going to be Snowflake next probably, and then I think probably Synapse. I don't know. We'll see. But certainly, Snowflake is definitely the next big one that we will hit. But yeah, we're moving it forward as fast as we can.
Awesome. And last question as we close up here. You've been in the database industry a long time. And if you were to fast forward another chunk of time, another 5 years, another 10 years, whatever significant, where do you see it going? Some people, when the NoSQL movement happened, they're like, "This is the demise of the relational database," or and so there's plenty of changes, and we think that there's changes that don't quite happen. But realistically, 5 years from now, 10 years from now, which things do you think they're just not going away because they're fundamental, and which things do you see changing and being radically different in the future?
I think the one thing we can say is that one, relational structures are not going away.
Mm-hmm.
If there was a paradigm shift, like now, that completely changed the way we can store and retrieve data, such that why would you put it in this relational data structure? It's a waste of your time.
Mm-hmm.
Cool. 5 to 10 years from now, they're still going to be going. Want to know why I know?
Because there's so much
I used
out
to
there.
work for a company. Yeah, I used to work for a company that was running 1970s hardware,
Mm-hmm.
right? We're still running 1970s hardware. I guarantee relational structures are going to be around in 10 years.
Oh, yeah.
They're going to be around in 20. And that's assuming that's assuming a paradigm shift. Without a paradigm shift, yeah, I think the one thing I could say is we are going to see more of the kinds of stuff that we're seeing today, which is, the expansion of relational structures into more and more bigger and broader stuff, JSON inside the database, that kind of thing. We're probably going to continue to see an expansion into cloud services, certainly. But I think the really big thing that we're going to see shifts on is consumption of data, not the collection of data. I think collection of data, I think that's a problem we've kind of solved. Again, NoSQL solves some of it. Relational structures solve some of it, and everybody's going to pick the right thing for the right job and go forward. The analytical side, I think that's where we're going to see big changes. Things like, not necessarily including, but things like ChatGPT, where AI is able to find where the data is, where I don't know which spreadsheet you put stuff in, but we've got this AI thing that's scrolling through all the spreadsheets, and it knows, it's over there.
Mm-hmm.
And so it can go and get it and pull it back in. And because let's face it, most data is in spreadsheets.
Yeah.
Most data is not in databases, sadly. But regardless, I think that the analysis of data is going to be shifting radically. And if I were a young man, which I am not, I would spend my time chasing analysis. I would be focused in that area, because that's where the most change and the most growth is going to occur in the next 5 to 10 years. I think it's going to be radical. I think in 5 years, it's going to be somewhat unrecognizable from where we're at today. And I think in 10 years, I'm going to be an old man at that point, and I'm going to go, what the heck is this stuff? I've never heard of it. I mean, it's going to be, it's literally going to be, like, I like the dial phone better. Said no one really, but I think that's where the real shift is going to be. And data collection is going to be roughly the same, because fundamentals are fundamentals, but analysis, oh my gosh, it's going to be a whole new world.
Awesome. Well, thank you so much. And this has been a pleasure. I learned a lot, really enjoyed our conversation here and sharing your experience on just everything holistically, as well as going deep into SQL Server performance tuning. And I'll remind the listeners to go get Grant's latest book, SQL Server Query Performance Tuning, November 2022 publication, so hot off the presses, and scarydba.com.
Thank you. And remember, statistics are important.
Awesome. Well, Grant, thank you so much for coming on the show. I really appreciate it.
Yeah, sure. No problem. Happy to.
Awesome. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.